Hello and welcome to Electrolytic Titration. In this demo, we will be investigating the relationship between electrolyte concentration and conductivity. An electrolyte solution contains an ionic salt, like shown at left, which is dissociated into water to create a solution that carries electric current. The positively and negatively charged particles in the solution are able to transfer electrons, thus conducting electricity. In doing this, they can complete an electric circuit, which can perform many tasks, such as lighting up a light bulb. In such a solution, ion concentration varies directly with conductivity. This is because with more ions available to transfer electrons, a greater stream of electrons can be transferred at a time, resulting in a heavier current. We will be titrating aqueous barium hydroxide with aqueous sulfuric acid in order to examine the relationship between conductivity and concentration. In the burette is 0.1 molar sulfuric acid, which will be titrated into 0.05 molar barium hydroxide. The solution will be stirred using a magnetic stirrer, and we will collect conductivity data using a conductivity probe linked to a lab quest. We will graph the data on the lab quest. In order to visualize the progress of our titration, we'll use the indicator phenolphthalein. This indicator makes the solution appear blue-green when basic and turns pink when acidic. Don't forget your goggles, it's time to start titrating. At this point in the experiment, the solution is green because the barium hydroxide solution is basic. Barium hydroxide dissociates partially, making the solution mildly conductive. As sulfuric acid is titrated into the solution, the color fluctuates as additional barium is dissolved and then neutralized. The conductivity continues to gradually increase. Past the equivalence point, there is a sharp increase in the conductivity of the solution. As the sulfuric acid ions are no longer needed to neutralize the barium hydroxide, the ions accumulate, creating a heavy concentration of ions and resulting in the high conductivity. At this point, the solution appears bright pink because it is acidic. Here is the graph created by the lab quest plotting conductivity versus time. Prior to reaching the equivalence point, the conductivity increases very gradually as the added acid must neutralize the barium hydroxide. At the equivalence point, the barium hydroxide has completely reacted. Beyond the equivalence point, no barium hydroxide remains to react with the sulfuric acid, so added sulfuric acid increases the ion concentration, resulting in an increase in conductivity. This results in a steep rate of increase of the conductivity. Unfortunately, we do not have access to an apparatus which could help us light a light bulb using the current in this solution. But in a perfect world, such as Titration Nation, we could use this demonstration to show the relationship between concentration and conductivity by lighting up a light bulb. Here is our titration setup. Instead of using a lab quest linked to a conductivity probe, we have a conductivity apparatus. A circuit using an outside power source lights up the light bulb. 2 electrodes descend into the beaker with the solution, and the electrolyte solution completes the circuit. Initially, the beaker contains barium cations which conduct electricity, lighting up the light bulb. As acid is added to the solution, the acid ions react with the barium hydroxide, precipitating barium sulfate and liquid water out of the solution. Because of this, the ion concentration decreases, as does the conductivity of the solution. Accordingly, the light bulb dims. At the equivalence point, the sulfuric acid completely reacts with the barium hydroxide so that there are no ions present in the solution. As it is no longer an electrolyte, there is no light in the light bulb. After the equivalence point, added acid increases the ion concentration of the solution, relighting the light bulb. As there is no barium hydroxide left to react with the acid, the ions accumulate, making the solution highly conductive and making our light bulb very bright. I hope you enjoyed learning something new about chemistry. Thank you for watching.